Hey everyone, it's Norm from Tested here, and here with
Jen from Tested.
Jen. It's so great to see you in the studio.
I know, it's great to be here.
Oh my gosh, it's been a while since we've done any type of build or filming together, but we thought we'd come back big. So
Yeah.
this is the X-Carve Pro, the big follow-up to the X-Carve CNC, which was actually one of the first things that we put together here in the Tested office.
I think it was my first time ever visiting. I'm pretty sure it was my first time visiting Tested. That was like the first thing that we did together.
It was such a fun project. It's a great machine. Inventables that makes the X-Carve, they sent this over for us to check out. And so in this video, we'll be talking about how it comes together and hopefully doing a first test cut. But in like the world of CNCs, this is supposedly an easy one to get into while being really powerful.
Yeah, this is going to be a lot more accessible than some of the other sort of desktop units that are out there because of the Easel software. So it's really streamlined, it's very user-friendly. You don't have to know a whole background of CAD and feeds and speeds, you can just dive right in. But I think what we're seeing with this machine versus the other X-Carve we built is this is big. It's really big and really beefy. So it's going to be a big upgrade from the original X-Carve.
Totally. You can see the parts that you've laid out, like the gantry, just for the X-axis is behind us. We had to split it across 2 tables. That's like 5.5 feet because it's made for full 4x8 sheets of plywood.
Yeah, we've got the 4x2 layout, which there's a 4x4 layout as well. So this is a narrow, long one, but what's cool about this is there's a tiling feature so you can pass your design through. So you could take a full 4x8 sheet of plywood and pass the entire thing through this machine while only having a really narrow footprint.
With the software doing the registration for you, recognizing, there's no cameras on this. It's not like the Glowforge pass-throughs, but I'm really curious to see how that's going to work. And it makes a lot of sense for garages and workshops where you don't have a lot of space. And like we found it difficult to store the first X-Carve if we're not actively using it.
Yeah, I think that this is the right type of machine for this sort of space where real estate is at a premium, but we want to have the functionality to do some larger scale pieces on occasion.
Absolutely. So you've done the part of unpacking everything. Can we run through just what some of these components are and an overview of how it all comes together?
Yeah, so with the 4x2, there's a shorter y-axis. So the y-axis comes in 2 pieces. There's one Y piece here, and I've got another one set up at the table back there. These are attached by a set of cross members. These go, I believe, under the wasteboard. So this one's got 3. So if you can picture, there'll be 1, 2, 3 crossbars, another Y-axis end cap down here, and then across the entire thing will be this beast of a gantry. This is absolutely monstrous. Like if you could feel how heavy this is, it's pretty serious. So that's going to go across the top of the whole thing. And then we've got the wasteboard over here on the table, 2x4, the controller, and then the big, this is the brain. This is the brain of the operation. And if you are familiar with the original X-Carve, this is quite a bit bigger. The original controller was maybe smaller than a shoebox, but this is like a huge desktop, computer situation. So it's big, and I think this is all the hardware, so it should be pretty straightforward, hopefully, to put together. Yeah, I'm ready to dig in.
All right, you've got the instructions printed out as well. We'll kind of go through a bit at a time. I'm amazed at these stepper motors. The spindle being built in. We're so curious about just the stability of this at this scale, how precise you can get. But yeah, let's start. What's the first step?
Okay, so first up, I've got everything out and knolled. We've got all of our different components here, and I believe the first step is to actually remove the covers. So remove the covers on the gantry and the end plates. So we've got a 2.5 millimeter hex key, which is this guy, and we're going to take the covers off the end of the gantry. So we've got all the pieces roughly laid out. Right now we're attaching the cross members to each of the Y-axes. We're just going to get those screws in place, and then because this is a physical assembly, we're going to square everything perfectly before we tighten it all down.
I feel like this is a place where if we don't do it properly now, we will pay for it at the very end. But one of the fun parts of assembly of the kit.
Yeah, gotta get it right. Now that we've finger tightened everything, we feel pretty good about square.
Yep.
We can torque it all down and commit.
Let's do it.
So this is set to 39.5 pounds, and it's got your, hopefully the correct bit in there. So I think go ahead and go for it. And you can probably adjust the ratchet.
Not quite a moment of truth, but definitely a moment of import. As you can see, we have our massive X-axis gantry elevated, but now we're going to marry this to this Y-axis assembly.
Yeah, we've got to maneuver it. It's heavy. We have to get it in the right position and kind of flip it and lower it and get all of our screws in the right position, kind of happening all in a smooth procedure.
Exactly. It's not a place where we can do an adjustment on the fly because we've already squared the Y-axis. So the crossbars on the Y-axis, we hope, are correct.
Fingers crossed.
We've measured out our adapter plates along the Y-axis. That's the big plates that get mounted onto the X-axis. And if all things goes well, then everything should be square, and we can breathe a sigh of relief.
Yeah, in a few minutes, hopefully.
Okay, let's do it.
Okay, so it's on. It's not tightened down yet, but we have it positioned. It's mostly in the right place. We're gonna measure all of our distances to make sure that it's in the right orientation, and then we can tighten everything down. But the biggest, most challenging part, I think, is set. All right, so I'm gonna measure my side and see how much. I'm gonna measure from this plate, the actual gantry plate, to the edge of the Y plate.
Got it.
Because that's the easiest. That's like what I can reach from here, I think. That'll do it.
Woo!
Yes. Okay, so now we can bolt it in.
Yes. Okay, Jen, what is next?
Well, it's all put together, so now we just need to plug everything in. All the electronics, we got to wire it all up.
I want to stop here for a second because when we put together the first X-Carve, it took us much longer to even get to this point where we're plugging the electronics in.
I think it was across 3 days that we built that whole thing. So this was, what, a couple hours maybe, if that?
Yeah, like an hour and a half to get to this point. Obviously, some heavy lifting. We don't know if everything is perfectly calibrated yet, and leveling, of course. But I think they learned a lot of lessons about what they want people to do when they buy a kit versus what they want to take care of in their manufacturing.
Yes, this has come a long way. There was a lot more that was just readily put together out of the box that we were just kind of putting one piece into connecting it onto another section as opposed to building every little component of the entire structure.
And thankfully, all the wiring is already attached on the gantry, and so we'll just plug it in at the end of that snake. That was much faster than I thought.
Oh my gosh, yeah, that's a wrap in a quarter of the time that it took us to build the other one.
Yes, and the thing I've also noticed that their larger model, right, which would be the 4 foot by 4 foot one, it's basically the same assembly, except you have a few more of the crossbars.
Yeah.
But the same gantry size.
Yeah, this would all be the same. This would just extend, and then you'd get two additional cross members. You'd have double the size of the wasteboard. But it should be about the same assembly, I would think.
So at this point, everything's plugged in. We have to get it connected to a computer, run Inventables Easel software to do some final calibration. But we'll be ready for our first cut soon.
Yes.
Okay, Jen, it's been, what, a couple weeks
Yeah.
since we got this set up. The room is laid out a little differently now because we've gone through a few more steps to get this set up. But what's been done? Can you go over what we've done to get ready for our first cut?
Yeah, there's a whole process. So we got the feet leveled. So the floor in this room isn't perfectly flat. It's not perfectly level. So it's important that we get it as level as possible. There's some feet on the bottom on all four corners. So we've adjusted those to get it within range. Then the next step, once you get the machine on, is to actually surface the whole wasteboard. So we put in sort of a fly cutter, which has teeth that go all the way around and will carve the whole surface of the board so that it's coplanar with the machine. So even though it's not perfect, like this is a very manual process, the planing of the wasteboard makes sure that the workpiece is going to be perfectly coplanar and parallel to your gantry, so your cuts are going to be nice and even.
And that's going to be specific to this machine. This compensates for any of the minor tweaks and misalignments that we may have had in our assembly.
Exactly.
You can see it's a very small little, it's pretty close. It's not like it's an off axis or anything, which gives me confidence.
Yeah, we did a pretty good job.
Yeah. And this also gives you a sense of just how big this machine takes up, right? Like the previous X-Carve, while it was a more square form factor, was massive. This is really wide. Like the weight of the spindle itself is going to be meaningful.
Yeah, and that's one of the things we had to sort of compensate for with our initial setup was the spindle and the gantry, as it moves to the back of the axis, the weight is sort of cantilevered out over the back. So we had to leave enough room for the whole gantry to move past the bounds of the machine, basically, and for that weight to be supported at the back so it's not going to tip the whole machine over. So it's definitely a much more substantial construction than the previous X-Carve.
I'm really curious to see the whole thing in operation, how stable everything is. Well, you've got a piece of material clamped in. Walk me through the process of calibrating and letting the machine know what it is we're about to cut and where it is on this 2x4 bed.
Yeah, so the machine has limit switches on each axis. So there's one on Z, there's one on Y, and there's one on X. And that will tell the machine exactly where its absolute zero is. I've positioned a workpiece on the wasteboard, and we have to tell the machine where this is located and also the dimensions of the workpiece. So I'll measure length and width on the actual material. I'll use calipers to measure the thickness so it knows where how deep it can go. And then within the easel software, I'm going to position the spindle where I want the workpiece 0 to be located, and then use that as reference so the machine knows this is where I'm going to position your cut in relation to the workpiece.
So the machine now thinks this is 0, 0. It's kind of a different way of, when I think about a laser cutter. It has like a very visual representation of the whole bed. And you would typically, line material maybe in a corner or something. But here it doesn't matter. It thinks it's 0, 0. It's not going to, the limit switches will prevent it from hitting the end, and you give some flexibility and versatility in where you clamp it down.
Yeah, and what's really great about Easel is you're getting a visual preview of what you're seeing. So wherever you're placing your design, it'll show you the size of the workpiece essentially in software. So you can actually get a sense of where it's going to go. You can simulate the cuts. You can see the path the spindle is going to take. Make sure you're not going to run into any clamps. All of that kind of stuff is sort of visually in front of you, so it's easy to get a sense in advance.
Yeah, and that's one of the things that we've been really happy with in the past with Inventables is the Easel web-based software.
Yeah.
You can do it at home, log in, upload your vectors, give it all the input, and that visual representation of the work path is just, makes it a little more user-friendly.
Definitely.
Including even like the end mill, like the size of the end mill, you're telling exactly, these are their clamping system.
Yeah.
They have a whole series of end mills that they sell.
Yep, they have a sort of proprietary clamping system, which I think is actually really clever. So it's a plastic piece that will stick out over your material, and then there are these different heights, sort of a stepped block, and the clamp fits onto that, and then you use one of these screws to go through and tighten the clamp down into threaded holes, which are across the wasteboard. So you can really use any size of material, any thickness. You've got flexibility with all these different sizes and position it anywhere that you need to.
Right. And this is CNC milling, so it's 2.5D. Essentially, we can tell exactly how much into the material to cut. I think for our first test cut, you have set up so just one depth. We're not going to go super complicated. It's not going to separate a piece from it, right? So no need to create tabs. Can we take a look at that vector, what we want to do, and what we hope to get out of this?
Yeah, definitely. Let's take a look at Easel. So we're here in Easel, and I've imported an SVG of the tested logo. Easel will import SVG files and sort of use them in whatever way you tell the software to use it. So traditionally with CNC, you'd have to import G-code and you'd have to figure out all your tool paths and your approach and your feeds and speeds and everything. Easel has simplified that entire process. So I just import the shapes and then I tell it whether I want it to be a pocket hole, whether I want it to be a contour cut, and then I can set the depth of the cut for each individual piece of the SVG.
So the shaded area is a pocket hole where I look at this, and for like a laser cutter, I would be thinking if I wanted to engrave that, it would have to be a rasterized image, like locked in. Here, just giving it the shape of the points and saying, you know, fill in, hog out that area.
Exactly. Yep. And I can tell it how deep I want this to go, and I can even set, like I could set each letter at a different depth if I wanted to. But I do have the option of cutting outside the shape, cutting path around it, but I want to do this as a pocket essentially, so it's going to carve out all of the negative space inside of the letters of the logo. So what you'll see actually if we take a look at the preview, if we zoom all the way in, we're just using a 1/4 inch bit. We're going to keep this pretty simple and not do a tool change. So you can't get the detail all the way in those sharp corners. We need a smaller end mill for that, but we're just going to try this with the 1/4 inch bit and see how it turns out.
And it's nicely visualized there too.
Yeah, we've got a
One of the best
preview.
things.
We can see, like I could position this on my material, and this preview is the same size as the material that I've set based on the measurements.
Yeah. And then we should also give, of course, disclaimers. This is going to be a machine where you want eye protection, you want ear protection. It's probably going to get loud. What are the last kind of things that you need to go through as a mental checklist before running this?
When I go to carve, when I hit this carve button, it's going to actually go through this whole checklist for me. So it's saying you've measured your material. I'm going to confirm all these. Clamp it down, which we've done. Material is secure. Set my end mill size, which is a 1/4 inch end mill. And now there's an option here to do either a manual or automatic probe. So the machine does come with a Z probe setup. So you would position this little brass puck on the top of your material, clamp this to the spindle, and then the spindle can tell exactly where it is in relation to the machine zero, essentially. We're going to set this up manually because I've positioned the piece kind of off of the machine zero. So I'm going to go through the whole process one by one for each axis.
Okay.
All right, now hopefully this is going to go where it's supposed to go. There's a chance it won't, but if it doesn't, I'm going to kill it. So here we go, curve. Nice. That looks so good with the red.
Jen, this looks super good.
I'm impressed. Yeah, the edges, you can really see with the paint, the edges of the cut it's really crisp.
Oh my gosh. And super rock solid, stable, move really, really fast.
Yes.
You know, it's powerful. You can tell it's a powerful machine.
Yeah, this is sort of just literally scratching the surface of what it can do because we did a very shallow cut, but you could do really beautiful, you know, big furniture pieces and things like that with a machine this powerful.
And we're going to be doing a lot more of those things in the future. This is really just establishing it here to give you a sense of what that setup is like, that workflow. For people like us, we can actually do some machining and it unlocks so many different project ideas. There are things that we're going to be testing with this as it comes out, as Inventable is also working on delivering this. So things like there's a dust shoe for dust collection.
Yep. That'll attach to a vacuum so that all of the chips that you're getting in the environment will pull up into the vacuum and you don't have to worry about so much cleanup.
And we specifically went for the 2 foot by 4 foot version, even though there is a 4 foot by 4 foot version, because we want to test one of the features, which is the ability to do tiling and have a sheet of ply that's maybe bigger than this bed, but do it in multiple passes and align them and register them.
Yeah. So you'd be able to take a piece of material that's larger than the actual wasteboard of the machine, start your design, tile it, pass it through, and then pick up where you left off to do a much longer cut.
All right, so X-Carve Pro now becomes a part of our tool set here at the Tested office. We'll be back with more projects on this. Very excited, very happy we got this working. A little bit of troubleshooting needed. And I'd be curious what your thoughts are and what you'd like to see us do with this machine in the future. But it's such a nice way to come back into the office, Jen, and get this machine set up.
New tool. I'm excited.